All right, guys, this is problem 136 from the homework. And let me just also say a little bit about the homework. It looks like only about 13 people have their accounts set up on Pearson. That means there's a lot of you that have not yet set up your account on Pearson, and ideally you would take care of that today. The first homework is due on Wednesday. So you only have today and tomorrow really to complete it. And that's because, we've got 6 weeks for the summer course, and so we've got to get through this stuff. Um, the first assignment isn't too bad. There's only 18 problems. And like I said, I'm going to be doing a lot of those problems with you. So some of them will be examples. But I wanted to talk about 136. So if you haven't yet set up Pearson, do that today if you can. It's going to be really important because you need to get started on the homework right away. You don't want to get behind because that would be, I don't want to say catastrophically bad, but it would not be good. So, if you don't have access to Pearson, get it today. Try and get access to it as soon as possible because you really need to start on the homework like right away. Okay, but let's take a look here at problem 136. I think it's a good problem. We're going to be using vectors to solve this one. Okay, and so this is a good example of our vectors here. Okay, so we've got the first part A here where we want to find the magnitude of our vector, and then we've got B where we want to find the direction of our vector. All right, so and let me draw a picture here of what I'm talking about. Okay, so uh, she starts out here at the start position and then she ends up here at the end. And what we're after in the first part is we want to get the magnitude of the displacement. That is how long is this arrow, right? The displacement is an arrow pointing from this where she started to where she ended up. And she's gonna first head south 0.8 miles, then she's gonna go east for 0.8 miles, and then she's gonna turn and go up here at some funny angle. Okay, at a 30-degree angle. And so then she's gonna go 1.2 miles or whatever the number. So yeah, 1.2 miles up that way. Okay. And so as with all of the problems that you're gonna do in this, you really need to draw a picture. And so that's what I'm gonna do here sharing and then switch to my webcam. Okay, so here I've made a diagram of the problem. Okay, and I actually went through all of the solutions here. So this is pretty much everything that you need to know about this problem. Here's the solution. But let's go through it together. Okay, so um it starts off here, and in the original problem I had, okay, she's gonna go 0.8 miles south. So this way is south. It's just like on a map. East is to the right, south is down, and then west is to the left, and then north is up on the map. Okay, that's how maps are oriented. Okay, so first it says she goes 0.8 miles down. Okay, so she starts up here, and this is our displacement vector, this light blue one. Okay, so that's our displacement vector. And so we're trying to find two things. Okay, first of all, we're trying to figure out what is the magnitude of this vector, which means how long is it? right? It's the length of the vector. The second thing is we want to find the orientation, but it says starting at east and going counterclockwise. Now, some old people say the kids nowadays don't know how to tell time. I don't think that's true, but counterclockwise is going this way around. Okay, so that's counterclockwise. So once we find this angle here, okay, then we're going to have to subtract it from 360 degrees to find that angle. We'll call it alpha. Okay, that's my big angle, alpha. So whatever we get for this little angle here, we have to subtract that from 360 degrees. And we're really, this is an upside down right triangle here. Okay, so we're going to use sine and cosine. It's a right, here's my, this is my 90-degree angle over here. Okay, but we need to find out right here, how long is this component? Okay, just this part right here. Now, we know that when she goes over here, she's going to travel northwards by some amount, this angle right here, that side of my angle right here. Okay, and we also need to know what this length is right here. Okay, it tells us, and see here we have another triangle. So this is our little, this is our right triangle down here. Okay, so we've got, she travels east by 0.8 miles. She gets right here. She turns 30 degrees north and travels for 1.2 miles, and then she ends up here. Okay, so this little triangle here, we've got the hypotenuse and we've got an angle. Okay, so we can get everything that we need to know. Okay, so then we're going to get, let's start with X here. We need to get, ultimately, we need to get this little piece up here, Y, but let's get the X part first. Okay, so X is 0.8 miles. So that's our first part right there. And then we need this bottom part of our triangle. Okay, well, let's look at our trig. Okay, so X is R times cosine of theta. So I mean that's R, it's supposed to be R cosine of theta, and R is our hypotenuse. Okay, R cosine of theta. That was supposed to be an R. Okay, so the hypotenuse is 1.2 meters, and we do cosine of 30 degrees right there. That's going to be the adjacent side of our triangle or the base. Okay, and so that's what X is. We have 0.8 plus this part here. Okay, and I am recording. Okay, good. Now when I do this, I put it into my calculator. Okay, and that gives me 1.8392 miles. And let me show you how I did that. Okay, let me share my screen with you. Okay, so for me, I use a program called MATLAB. I don't think I need to get a scientific calculator. But in MATLAB, okay, and this is free. So it's just 0.8 plus 1.2 times cosine d of theta. The d tells MATLAB to do it in degrees, cosine of theta. That gives me 1.892 meters. Okay, so that's how I did that for the first part. For y, okay, for y, we know that from the bottom here up to the top, that's 0.88 miles. Oh, this is in miles, not meters. I kept saying meters, but it's actually miles. Okay, this whole thing is 0.8 miles, but we just want this little piece up here. Okay, so we need to figure out how far she went north and then subtract it from the total distance. Okay, so the key with this problem is we have to read it and draw this picture. Man, if you don't draw this picture, it's basically impossible. I have to draw a picture, otherwise I can't do this. Okay. So that means I've got my total distance here, 0.8. Okay, and I'm gonna subtract this little piece of the triangle right here. I'm gonna subtract that. So that'll be, and I'm gonna use sine of theta, right? Because sine is the opposite equals the hypotenuse times times sine of the angle. So here's, I'll write down y, right? Equation is r times sine of my angle theta, oh man, I messed it up. R equals R times sine of theta. Don't put in the numbers yet. Okay, you always should write down the equation symbolically first. Okay, so R times sine of theta. So theta is 30 degrees. My hypotenuse is 1.2. That's supposed to be miles. I don't know. I just switched to meters. Okay, times sine of 30. That's going to give me that little piece right there, and it comes out to 0.2 miles. Okay, so now we've got the sides of our triangle. Okay, so this side up here, x is going to be 1.8392 miles. I'm not going to throw away those extra digits yet. I want to keep those. I don't want to, if you throw them away too soon, you'll get round off errors when you calculate. So don't throw away the digits yet until the end. Okay, so now we've got the the base of our triangle and the opposite side. Okay, and it's you can say this is an upside down triangle, right? It's just pointing downwards, which means that y, if it's a vector, is going to be negative. Okay, so when we put in for our angle here, right? We're going to do that later. We're going to do y over x, right? Here, I'll write down tangent. Okay, tangent of theta equals y over x. Again, these are the main trig functions. Oh, I shouldn't have wrote it so closely here. Okay, so tangent of theta equals y over x, right? Okay, so here we've got these are our equations. Yeah, these are really important. There we go. Okay, we want to keep these guys. Yeah. I'm going to put a circle on those because these are very important and a little star there. Okay. Yes. Muy importante. Okay. So now we've got the two sides of our triangle. We can get, okay, and now we can just, since this is a triangle, we can use the Pythagorean theorem. Okay, you can do it with vectors, and I think I showed that in a video. Okay, but basically we're just gonna find the hypotenuse here of our triangle. And so r is going to equal the square root of x squared plus y squared. And so I can put in my numbers here. R equals the square root of 1.8392 squared plus zero point 0.2 squared. Okay. And let's see, did I already calculate that? What those are? What was my length? Oh, okay. So down I calculate. Oh, well, anyways, I don't know if I put it in my calculator and got an actual number, but I could. Okay, that's pretty easy. Okay, so just plug that into your calculator. Boom, you're done. Now that I have X and Y, now I can easily find my angles. Technically, this is negative since it's pointing down. Because so I have tangent of theta equals y over x. I know y. I know x now, and I take the arctangent of both sides. Arctangent of tangent of theta is just theta. Okay, so I get theta equals, so theta equals this, equals the arctangent of minus 0.2 over 1.8392. And so I get that angle right here is that for me and my numbers, that was about 6 degrees, 6.2061 degrees. And so I subtract that from 360 degrees, right? Because the problem asks you, what is this outer angle here? Alpha. Okay, so I have to subtract the angle from inside my triangle there. That's going to give me the whole angle right there. Okay, and so since I had two significant digits, if I just subtract this, right, I got 353.8 degrees, but I only had two significant digits, so I end up with, that means it's 358 degrees. Okay, but Pearson would take 353.8, but the numbers only had two significant digits, so you can just you can just do that. Okay, so that is problem 136. Here is this is a good problem because you have to do some vector addition or some vector operations, and then you have to draw this diagram. All right. Thanks for watching. I'll post more videos, and then the chapter 2 videos will be up later tonight after I make them. Thanks for watching.